This video is about pressure. Pressure is the normal force exerted by fluid in a system on the inner surface of the This video is about pressure. Pressure is the normal force exerted by the fluid in a system per unit area of the inner surface of the boundary of the system. Pressure is a scalar quantity. It is independent of direction, and the pressure at any point in a system has the same magnitude in all directions. We need to differentiate gauge pressure and absolute pressure in engineering practice and also in engineering thermodynamics. For pressures above atmospheric pressure, let's take a look. Here is the zero pressure, absolute zero pressure. When you have a vacuum, system, then the pressure should be absolute zero. Then you have the pressure of the atmosphere. Let's call it P atmosphere. And you have a pressure of the system that is above the pressure of the atmosphere. So the difference between your pressure and the absolute zero, this is the absolute pressure of the system. Oftentimes we consider the difference between your system pressure and the atmospheric pressure, P gauge. So this is a gauge pressure. When you have pressures below atmospheric pressure, this is what happens. You have a P2 that's below the pressure of the atmosphere. Then the absolute pressure is still the difference between your P2 and the absolute zero. However, when you have a pressure that's lower than atmospheric pressure, we often use something called a vacuum, P vacuum. That's the difference between the atmospheric pressure and your absolute pressure. And it should be a positive value, this P vac. So in terms of pressure measurement, there are many things we can use to measure pressure. We can use a manometer, which uses a liquid column to measure the difference in pressure between your system and the environment based on the column levels difference. We can also use a barometer to measure the pressure of the atmosphere. That's a special type of a manometer that's used to measure the atmospheric pressure. And I have a separate video on barometers. Now, with the advancement of electronic technology and transducers, often we use electronic transducers to measure the pressure of a system, or the difference between the pressure of your system and the surroundings. Here's an example of a mechanical measurement of pressure, and this particular instrument is called a Bourdon tube. It measures the gauge pressure. It always measures the gauge pressure because when you look at the back of this instrument, this device, it's a curved tube that's connected to the system of which you're measuring the pressure. However, this entire tube is exposed in the atmosphere. So how much this tube bends or curls depends on the pressure difference between the inside of that tube, which is the system pressure, and the pressure of the atmosphere, which is outside the curved tube. So this is the so-called Bourdon tube pressure gauge. It measures the gauge pressure of a system.